This is the lesson 7 PowerPoint on power production. You need to have your student handout so that you can fill in the notes as we go through this. Nuclear power. This is the Chalk River nuclear plant in Ontario where many radioactive isotopes that have been used to fight cancer were produced. Nuclear reactors are one way these isotopes can be produced. They can also be made in facilities like the synchrotron that is located in Saskatoon. There's only one nuclear power plant in Saskatchewan. It is a small experimental plant located at the Saskatchewan Research Council on the University of Saskatchewan campus and has been in operation since 1981. Inside the nuclear plant is a loop that contains a coolant. It goes into the reaction chamber, where it is heated. Now that the coolant is hot, it flows to the heat exchanger, where it gives off heat to the water that is being boiled. It then flows back to the reaction chamber to be reheated. Now let's talk about the reaction taking place inside the reactor. A uranium-235 atom is hit with a slow-moving neutron. Each uranium-235 atom that is hit will break apart, producing 2 smaller elements, 3 new neutrons, and a lot of heat energy. This could quickly get out of control as 1 neutron becomes 3. And if those 3 successfully collide with uranium-235 atoms, 9 neutrons will be created. That can become 27, that then could become 81, that then may result in 243 neutrons, and so on. So the reactor needs some way to slow the reaction down if too many neutrons are being produced and the temperature inside the plant starts to become too hot. So the plant uses control rods that can be lowered into the reaction chamber. These control rods absorb neutrons, so there are fewer inside the reaction chamber. If the reaction cools too much, the control rods can be lifted out of the reaction chamber and the number of free neutrons will again begin to increase, resulting in more reactions and creating more heat. When the coolant enters the heat exchanger, it is at a temperature of around 315 degrees Celsius. That is hot enough to boil water in the heat exchanger. Once the water is turned to steam, the steam pushes the blades of a turbine, causing it to spin. The turbine is connected to the generator, and when the generator spins, it creates electricity. After the steam has turned the turbine, it hits cool coils that causes the steam to condense from a gas to a liquid. That hot water is then sent back to the heat exchanger, so it can once again boil into steam. In turning the water into steam, the coolant loses heat. It enters the heat exchanger at 315 degrees Celsius, but will leave at about a temperature of 275 degrees Celsius. To condense steam into water, the steam must hit something cold. Typically, this is done by having the steam come into contact with pipes circulating cold water. The steam starts to warm up the pipes, so the water inside has to be cooled. This is where the cooling tower comes in. Nuclear power plants are often recognized by their cooling towers. The warm water leaving the condenser is carried to the top of the cooling tower. The water is sprayed out at the top of the tower as droplets to increase surface area. This increases cooling ability. As they fall, the water cools. It is then sent back into the system to help further condense more steam. Looking again at Chalk River, we can see that there aren't any cooling towers, and that is because the Chalk River nuclear power plant was built on the Ottawa River. So to cool the facility, they would draw water in from the Ottawa River, and then they would release that water back into the Ottawa River. In its prime, Chalk River produced 1/3 of the world's total radioactive isotopes used for cancer treatment. The reactor was shut down for the last time at 7 p.m. on March 31st, 2018. Nuclear power does not produce greenhouse gases or acid rain. It does produce nuclear waste. It is not renewable, and material going into the facility must be mined, refined, and transported. Advantages: Saskatchewan has lots of uranium. Short-term cost is low, requires little space, produces radioactive isotopes that are used in cancer treatments, and very little waste is produced. Disadvantages. In most cases, the uranium has to be enriched before it can be used, which requires further processing. The waste is extremely dangerous to all living things. The cost to store nuclear waste is high. Nobody wants nuclear waste near their home. Potential major disaster if a mistake is made, and waste is dangerous for over 100,000 years. Next is hydroelectric power. A dam is built across a river to block water. As it blocks the water starts to build up behind the dam. The higher the water gets, the more pressure will build up. When opened, water will then flow through a path past a turbine, cause the turbine to spin, and then it gets released at a lower point. So the higher the water builds up, the more pressure. So when it opens up, it'll spin the turbine even faster. When the turbine spins, it's connected to a generator that spins the generator, and when the generator spins, it produces electricity. This is the limestone generating station. It's the largest electrical producing dam in Manitoba at 1,300 megawatts. I put a URL at the top. If you type that in, this website has a number of videos that you can watch that tell you about different dams located inside of Manitoba. Hydroelectric dams do not make greenhouse gases, they do not make acid rain, they do not produce nuclear waste. The water is renewable. There is no mining, refining, or transportation that has to happen. Advantages. A hydroelectric dam creates a lake for recreation, for boating and fishing. It helps with flood control downstream of the dam, and also the water that has been collected behind the dam can be used for irrigation. That's for watering crops. We can see this is the case with Gardner Dam, which produced Lake Diefenbaker in southern Saskatchewan. Disadvantages. It affects migration of fish and some mammals. You lose some river activities like kayaking and canoeing. There's a loss of habitat for some animals like the beaver, and you need a river with enough flow and high enough banks. That's a problem in Saskatchewan because most of our population is in the southern part of the province, and there aren't very many rivers that flow through the southern part of the province, and you usually can't find banks high enough to build up enough water to make a hydroelectric dam feasible. Also, when the dam is built, you lose a lot of land for farming and housing. Next are coal plants. This is a picture of Boundary Dam in Estevan. It's the largest power plant in Saskatchewan at 824 megawatts. Continuously, there are trucks pulling up to the power plant that are loaded with coal. That coal gets dumped into the plant, gets crushed into a fine powder. It then gets mixed with air and gets blown into a giant fire. So that fire is continuously going and spinning around. That fire heats water that turns into steam. The steam pushes against the turbine blades, causing them to spin. They then hit cold pipes that causes that water to recondense into a liquid. Then that liquid goes through that whole entire process again of being turned back into steam, and then it recondenses into water, then back into steam, and then recondenses back into water. The plant in Estevan is on the Souris River, so cool water is drawn in from the river, and it is used to help recondense that steam, and then that water, now that it is warmed up, gets pushed back into the Souris River. As mentioned, the steam hits the blades of the turbine, which causes the turbine to spin around. The turbine is connected to the generator, which then spins, and when the generator spins, it produces electricity that gets shipped to our homes. Burning coal produces greenhouse gases and acid rain. It does not produce nuclear waste. It is not renewable. It needs to be mined. It does not need to be refined, and it needs to be transported. There are trucks continuously bringing coal from the open pit mines just outside of Estevan to the plant. Advantages: there is a lot of coal in southern Saskatchewan. It's easy to mine and it's cheap to produce. Disadvantages: strip mining affects animal habitats, and that's something you've probably noticed if you've ever driven to Minot, because as soon as you pass Estevan, you can see where they have been strip mining. Next are solar farms. This is done several ways. One of the two most common methods is using parabolic mirrors, as seen here. The sun's rays are concentrated by mirrors to hit molten salt that's inside of a tube. The molten salt is at 300 degrees Celsius. Once it gets to the mirrors, the sun's rays heat that molten salt up to 550 degrees Celsius. That molten salt passes through a heat exchanger, and that hot salt gives off its heat and turns water into steam. That steam then gets pushed against a turbine that causes the turbine to spin. The turbine is connected to the generator, and when it causes the magnets inside the generator to spin, it creates electricity. After the steam has hit the turbine, it travels down towards the condenser, where it hits cold lines that will turn that steam back into water. It is still hot water, and that hot water will then be returned back to the heat exchanger, where the heat exchanger will turn it back into steam. The water inside the condenser will then have to be cooled, so they may wind up using a cooling tower to cool that water back down or some other method. The other type of solar farm uses a whole bunch of mirrors that direct the sun's rays to a single spot. This is probably similar to something you've done in class at some point, where you took the phase sphere calculator and directed the sun into someone else's eyes. So the sun's rays come down, they hit the mirrors, and then bounce to a single point up here. When they hit this single point, there's so many sun's rays concentrated at that spot, it starts to superheat that point. So out in the field, there's a giant tube. Molten salt enters the tube at 300 degrees Celsius, and then will leave at 550 degrees Celsius. That molten salt is taken right to the top of the tube, where it will be superheated. And it is superheated because the sun's rays hit the mirrors that are out in the field. Those mirrors reflect that light to a single point. And when it hits that single point, it will superheat that point. That molten salt then travels to the heat exchanger, where it will then turn water into steam. That steam will turn the turbine. The turbine starts spinning. It will spin the generator, which will produce electricity. The steam then will recondense into hot water and then run through the entire system again. Once the solar farm is up and running, there are no greenhouse gases produced, there is no acid rain, there's no nuclear waste produced. It is renewable. Nothing has to be mined, refined, or transported. Solar farms are cheap to maintain once built. Disadvantages: it does not work at night, if cloudy, or well in the winter when we need electricity the most, and they do take up a lot of space. Photovoltaic cells take sunlight and through a chemical process turn sunlight directly into electricity. The advantages are the same as the previous. No greenhouse gases are produced, there's no acid rain or nuclear waste, it is renewable. We do not need to mine, refine, or transport materials to the facility. Advantages: if you can get a net meter on your house, you can lower your energy bill. When you're producing more electricity than you're using, you get credited for the electricity that you put into the grid for other people to use. It can also provide power in remote areas. So if you have a cabin out on an island and it cannot be connected to the SAS power grid, you can collect your own energy, and it doesn't take up usable space because it goes on your roof. Disadvantages, again, it does not work at night or well if cloudy or in the winter when we need electricity the most. It can also be damaged by high winds or hail. Next is the production of electricity through geothermal energy. When geothermal energy is used to produce electricity, they take water and they push it below ground. It is so hot where they conduct geothermal energy for electricity that the ground is able to heat that water into steam. And the steam then pushes the blades of the turbine. When the turbine spins, it spins the generator producing electricity. They then recondense that steam into water, and then that water is pushed down below ground again. Advantage: it does not produce greenhouse gases, acid rain, or nuclear waste. It is renewable. It does not require mining, refining, or transportation of materials. Advantage: it's cheap to maintain once built. Disadvantages: it covers up nature's wonders that could be used to bring in tourism. It'd be detractor for people who want to go to places like Yellowstone National Park. Also, there are no hotspots in Saskatchewan. There isn't enough heat directly below the Earth's surface where we're located to produce geothermal electricity. How is geothermal heating used in Saskatchewan? Many people have started to use geothermal heating to regulate the temperature of their house. If one digs down far enough, you will find a depth in the ground that is comfortable temperature for people, and it is deep enough that the temperature does not change year round. People run pipes through this area of constant temperature that are connected to pipes that run under their flooring of their house. Since the water is continuously circulating, the house stays the same temperature year round. This helps to reduce energy bills because the fluid circulating in the pipes keeps the house a constant temperature. That means you need less AC in the summer, or a furnace in the winter doesn't have to work as hard, unless the temperature outside becomes really extreme. Next is natural gas. This is Queen Elizabeth Power Station in Saskatoon. It's the largest natural gas plant in Saskatchewan at 430 megawatts. Not all natural gas plants run 24 hours a day. Usually, they are turned on at peak times. That's when people are using more electricity. The province will fire up the natural gas plants to make sure there's enough electricity to meet demand. The way it works: natural gas is pumped into the facility. It is burnt to produce heat that will turn water into steam. That steam then turns the turbine. The turbine spins the generator, producing electricity. That water is then condensed and runs through the whole entire process again. They may use a cooling tower. In Saskatoon, it is built on the North Saskatchewan River, so they will bring in cold water from the North Saskatchewan River to condense the water back to steam, and then that water is returned to the South Saskatchewan. Natural gas does produce greenhouse gases, but it is a clean burn, so it does not produce acid rain. It does not produce nuclear waste. It is not renewable. It does not need to be mined, nor does it need to be refined, but it does need to be transported to the location of the power plant via pipeline. Advantages of natural gas: there is a lot of natural gas in Saskatchewan. It's easy to access and it's cheap to produce. Disadvantages: leaks can result in death and loss of property. We all remember the explosion that happened at Regina Beach, and that's because of a natural gas leak. Next is wind power. Wind blows against the blades of a big fan, and when it starts to spin, that is the turbine, and the turbine is connected to the generator. So when the turbine spins, it starts to spin the generator, and it produces electricity. Wind does not produce greenhouse gases, or acid rain, or nuclear waste. It is renewable. You don't need to mine, refine, and fuel does not need to be transported. Advantages: there is a lot of wind in southern Saskatchewan. Disadvantages: well, it's not always windy. Some people claim living by them cause migraines, loss of sleep, and health problems. It affects some birds and disturbs the ground beneath the propellers and requires a lot of land. Although that point has been argued, that the actual footprint of wind power is quite small. Even though a wind field may take up a lot of space, you can still use the land that's below the windmills. Once called biomass, now more commonly known as a waste-to-energy plant. Garbage is burnt, and the heat from the burning garbage is used to turn water into steam. The steam turns the turbine, which spins the generator. The steam is then recondensed so that it can run through the whole entire process again. It does produce greenhouse gases and acid rain as materials are being burnt. It does not produce nuclear waste. It is renewable because people are always producing more garbage. It does not need to be mined or refined. It does need to be transported to the facility, but instead of taking the garbage to the local dump, you would be taking it to the biomass facility. Advantages: I think we could consider it renewable because humans always make more garbage. Fuel is already being transported, just taken to a different location. Provides job opportunities for people to sort materials, much like sorting that happens at Sarcan. Some garbage is already burnt. Now it could be put to use, and you wind up with smaller landfills and less maintenance. Anytime you go to drop off garbage at the local landfill, there's someone there to confirm that you're from the town of Lumsden or the RM of Lumsden, because landfills are expensive to maintain. And nobody wants people from different areas dumping stuff into their landfill. Disadvantages: must be monitored. Some garbage is harmful when burnt. Finally, let's look at cogeneration. Many industries produce unwanted heat. Cogeneration uses that heat to produce electricity by boiling water to produce steam that turns a turbine. But that heat may also be used to warm buildings during colder months, so less resources are needed to keep buildings at a comfortable temperature. Advantages: it lessens the need to make electricity by other methods. It does not produce extra greenhouse gases, acid rain, or nuclear waste, and it helps get rid of that unwanted heat, which oftentimes is a problem for industry. Disadvantages: you must live by the industrial facility, which, if it is like the refinery in Regina, the air quality is very poor, and there is not a lot of industry in Saskatchewan. When we do things that lessen the amount of energy we consume, power companies do not need to produce as much energy. They then burn less coal or natural gas. They need less land for wind or solar farms. They produce less nuclear waste. They have to dam fewer rivers. It reduces the production of greenhouse gases. We also produce less acid rain. We allow the air to be a little bit cleaner, and we allow animals and other people to be a little healthier. When we did the lesson on cost of power, we saw that when we leave light bulbs burning, it really doesn't cost us a lot of money. When we use electrical items, it doesn't really affect our power bill that much. What we got to keep in mind is the reason we want to turn those lights off, or we want to make sure that we aren't drawing power when it isn't necessary, is because that affects our health. That affects the health of all living things. All methods of creating electricity have a negative impact on the environment.